All right. Well, good morning or good afternoon, depending on when you're watching this. This should be Tuesday, and we're going to stay with section 8.2. Oh, I'm waiting for. Okay. And like I said yesterday, I'm going to put the weekly schedule up. So here's kind of the home page again. And Tuesday, we're going to do section 8.2 video notes, and then we're going to jump into chapter 9 and then have a test next week. And so we're just going to try and keep it through 1 week at a time. Right now, nothing on Friday. Hopefully that doesn't have to change. Kind of give you a break there. But that's just, again, the Canvas homepage under modules. Everything should be the same listed in terms of we're now chapter 8. Look under that module. I'm a little slow here. Let's see what happens. Hopefully you got an idea what 3x3 systems look like. And yep, so down here at the bottom, I got chapter 8 and 9, and then section 8.2 from yesterday, and then here's today. So obviously you probably already opened that. Now, from yesterday, let me get rid of me. Here are your answers, and I will post the key with the work Wednesday morning since it's due Tuesday at midnight. But at this point, I'm fine. As long as you know they are, you got to come up with the answers. The biggest thing is you make a little mistake. An algebra mistake in the beginning, it is so difficult to find. So always double, triple check what you're doing going through your work there. All right, we did not do any word problems, so I do want to take a look at one here. This is number 51 on page 814. Okay, so this is the actual problem. I got it written out. You don't have to turn in your book, but just know that's where it is. Let's do this. And the main thing is being able to set up the equation. It says a vending machine's coin box contains nickels, dimes, and quarters. You can use A, B, and C, X, Y, and Z. You can use N, D, and Q. Doesn't matter. The total number of coins in the box is 300. The number of dimes is 3 times the number of nickels and quarters together. And that should say if the box contains $30.05, find the number of nickels, dimes, and quarters that it contains. All right, so we got to come up with some equations. Now, here's the general rule of thumb. If we're looking for 3 things, you got to have 3 equations. You only come up with 2. You'll never, unless it's a little different situation, you're never going to be able to isolate a variable. So we got to come up with 3 equations. I'm just going to use N, D, and Q. The number of coins in the box is 300. So you just add up the coins and you get 300. So that could be 100, 100, 100. Who knows? But that's the case. All right, the number of dimes. All right, I'm going to do this on the side first, just a little bit of scratch work. The number of dimes is means equals 3 times the number of nickels and quarters together. All right, well, how do you represent that? 3 times the number of nickels and quarters together. You're going to have to put that in parentheses. You can't do 3n plus q. It has to be 3 times the quantity, n plus q. Now, we're used to, now you can leave that as d equals 3n plus 3q, but a lot of times we're used to having the constant over here. This may be something you substitute in. We'll take a look here. Or you may write this as d. Well, let's see, if we keep it in order of the n's, I'd subtract 3n. You could put minus 3n plus d minus 3q equals 0. You could do that. I'll wait for a second on that one. All right, and the box contains $30.05. Well, there's an equation right there. All right, so you have to take the value of each coin times the number of coins. So 0.05 n plus 0.10 d plus 0.25 q equals, and that's going to equal 30.05. And now I have negative 3n plus d minus 3q equals 0. You can use that, or you could use substitution where you plug in 3n plus 3q into your first equation and into your second equation. Doesn't matter. All right, well, here's your key. You got these 3 equations. And all right, a little bit of a clue here with this second one. To make life a little bit simpler, not that you have to, but you're dealing like 0.05, 0.1, 0.25. you can make these into whole numbers by multiplying by 100. So if I multiply everything by 100, so if I take that times 100, you get 5n plus 10d plus 25q equals 3005. Basically, you're going to move your decimal point 2 places to the right. Makes it a little bit easier. All right, so let's take a look here. I got n plus d plus q equals 300. I got 5n plus 10d plus 25q equals 3005. And I got negative 3n plus d minus 3q equals 0. I'm going to go through elimination and see what we can eliminate. I'll call this equation 1, equation 2, equation 3. Again, you don't have to multiply that by 100. Just makes things a little bit easier. I think I'm going to eliminate d. Okay, I'm going to eliminate d. And let's take a look at equation 1 and 2. So what I need to do is I need to take, if I'm going to eliminate d here, that's a positive 10 and 2. I'm going to multiply equation 1 by negative 10. So it's going to give me negative 10n minus 10d minus 10q equals negative 10 times 3,000, which should be negative 3,000. And now I have equation 2, which is just 5n plus 10d plus 25q equals 3005. All right, let's see what we get here. I get negative 5n. Those add up to 0 plus 15q. And it looks like I get 5. Now I got to eliminate d with either 2 and 3 or 1 and 3. I'm going to do 1 and 3, and I'm going to multiply 1 by negative 1. And that's going to give me negative n minus d. Let me just circle this one here or highlight it so I can come back to it. Minus q equals negative 300. And then I got negative 3n plus d minus 3q equals 0. Negative 4n, those add up to 0, minus 4q equals negative 300. All right, here's the whole goal, is to come up with a 2 by 2 system. So you break it down, 3 by 3 now reduces to 2 by 2. So I have negative 5n plus 15q equals 5, and then I got negative 4n minus 4q equals negative 300. All right, I need to get rid of a variable. I think I'm going to multiply the top one by 4 and the bottom one by negative 5. And again, double, triple check, which I'm going to need to do, so hopefully I don't make a careless mistake here. That gives me negative 20n plus 60q equals 20. And then this gives me negative times a negative. That should be positive 20n. Negative times a negative plus 20q. And negative times a negative. What's negative 5 times negative 1,500? Or 300, that's 1,500, right? And now 60 plus 20 is 80q. It looks like 1520. Divide by 80. And so I'm going to take 1520 divided by 80. And I get 19. Okay, so Q equals 19. If you get a decimal for this type of problem, then you're absolutely made a mistake somewhere, because you're dealing with number of coins. You can't have 2.4 coins. So we got 19 quarters. Well, take one of your two original equations. Let me use the negative, not original, but the ones that are circled in red. So Q is 19. Substitute that in. negative 5n plus 15 times 19 equals 5. Negative 5n plus, what do I get there? 15 times 19, 285 equals 5. Subtract 285, subtract 285, negative 5n equals negative 280. Divide by negative 5, n equals 285 divided by, or is it 280? 280. 280 divided by 5, since they're both negative, it'll be positive. I get 56. So I get 56 nickels, I got 19 quarters. If you look at the very first equation, you have to have 300 coins. N plus D plus Q equals 300. So N is 56 plus D plus Q, which is 19, equals 300. 56 plus 75 equals 300. Subtract 75. D equals 225. So 56 nickels, 225 dimes, and 19 quarters. Now here's the issue with this whole thing is if you mess up any of these equations up here, if you mess any of these up, and it's not going to work, and you're just going to spend a ton of time going through here, and you won't be able to figure it out. So you really got to be careful setting that up. All right, as I said, I don't know if I mentioned earlier, I meant to. There's no guided notes today. I think it was posted on the Canvas part. Just kind of follow along here. There's not a ton of terminology or notation to write down. I don't expect you to memorize this. This is nothing. I just want to go over this. But this is just some little bit of terminology. Inconsistent system. It means no solution. If it's consistent and dependent, okay, they depend upon one another, you get infinitely many solutions. Consistent and independent is one solution. All right, this is the one solution which you do the majority of the time. 2x2 systems, a little bit more straightforward. No solutions, parallel lines. Consistent, dependent is the same line. Well, once we get into 3x3, as I showed you yesterday, you have all those different things that can happen with the 3 planes. And your answers are going to kind of be a little bit different here. But we're going to take a look at what happens when you get no solution, what happens when you get infinitely many solutions. Okay, we've already done one solution. Basically, that is where all 3 planes intersect in one point. All right, go ahead and copy this down. And let's solve this system. And now just the 1, 2, and 3 just refers to the equation. Equation 1, equation 2, equation 3. (2x plus 2y plus 2z equals 12). Negative 3x plus y minus 11z equals negative 6. And 2x plus y plus 4z equals negative 8. All right, let's solve it. Substitution or elimination. Either way, I'm going to use elimination 95% of the time. I'm going to eliminate y. Okay, I got it. It lines up pretty good. Let's work with equation 1 and equation 2. Well, equation 1 is 2x plus 2y plus 2z equals 12. And equation 2 is negative 3x plus y minus 11z equals negative 6. All right, for this to work, I need to multiply equation 2 by negative 2. First one will stay the same. Second one now is positive 6x minus 2y, positive 22z And then negative 2 times negative 6 is positive 12. 2 and 6 is 8x. Those cancel, plus 24z. And now that's 12 and 12, 24. If you did get a 0 there, that's fine. You're allowed to get 0. All right, let's just take equation 2 and equation 3. Let's multiply equation 2 by negative 1 so that we get a negative y. And then negative 3x plus y minus 11z equals negative 6. And then 2x plus y plus 4z equals negative 8. That gives me 3x minus y plus 11z equals 6. And that gives me 2x plus y plus 4z equals, I need to be careful there, negative 8. Combining those, I get, what is that, 5x plus 11 and 4 is 15z equals negative 2. All right, this is our goal. Get a 2 by 2 system. So now I got 8x plus 24z equals 24. I have 5x plus 15z equals negative 2. Let's see, to get rid of, let's get rid of the x's. They're a little bit smaller than the z's. I'm going to multiply the top by negative 5, the bottom by 8. Negative 5 times 8, negative 40x. Negative 5 times 24. Make sure I don't screw up. Negative 120z, and negative 5 times 24 would be negative 120. 5 times 5, or no, 8 times 5 is 40x. 8 times 15, I believe that is 120. Positive 120z equals 8 times negative 2, which is negative 16. All right, we're looking to get rid of the x's. Negative 40 plus 40 is 0, but what happens? We get negative 20 plus 120. That is 0. So this whole side adds up to 0. This is negative 136. This is a case here. 0 equals negative 136. That can't happen. No solution. Now, we don't know exactly what that means in terms of what these look like. You know, these two planes could be parallel, and this one intersects them. They all could be parallel. They could just all not intersect at a single point. So for whatever reason, there is no ordered triple that solves all three equations. Okay, there's no ordered triple that solves all three equations. So no solution for this. We are done. Okay, you just need to identify that. You come up with a false statement. Okay. Now let's take a look at this one here. X minus y plus z equals 7. 3x plus 2y minus 12z equals 11. 4x plus y, minus 11z equals 18. So we want to solve that. All right, I'm going to get rid of the y again because of it lines just easiest. So let's take equation 1 and equation 2. Now, to get rid of this, I actually need to have that. I want this negative y to be a negative 2y. So I'm going to multiply that by 2. And that gives me 2x minus 2y plus 2z equals 2 times 7, which is 14. And I got 3x plus 2y minus 12z equals 11. 2x plus 3x is 5x minus 10z. 14 plus 11 is 25. All right, I think I got enough room here. I'm going to take equation 1, and I'm going to take equation 3. Now, I got a negative y and a positive y, so I don't need to multiply either one by anything. So even though I don't have a ton of room, I don't really need it because I'm not going to be working to the right. And what do I get here? So x plus 4x is 5x. Negative y and positive y is 0. Minus 10z equals 25. All right, what do you notice at this point? Okay, what do I notice? Got the exact same thing. I get 5x minus 10z equals 25. I got 5x minus 10z equals 25. It's not always going to work out exactly this way. So I'm just going to go through these steps more often. You're not going to. You don't need to if you recognize this. But just in case it's not exactly the same, what's going to happen when we add these two together is they're going to add up, and you're going to get 0 equals 0. Infinitely many solutions. Okay, we are not done. This ends up being a little bit more complex than a 2x2 system. So infinitely many solutions. If it's a 2x2, they're the same line. Well, this is your 3 planes. They could all be the same plane, or they could be 2 planes that intersect, and the third one intersects in a line. So we got infinitely many solutions. I want you to list 3 solutions. All right, and you're also going to have to list the solutions. And I'll show you how to do this. You're going to have to list the solutions in terms of either x, y, or z. I prefer you to list them in terms of z if you can, and I'll explain what that means. So you're going to list as order triple, because it's not every point, every order triple is not an answer. Like the point 1, 1, 1 clearly doesn't work. Okay, it doesn't give you 7, doesn't give you 11. So there's actually more answers that don't work than do work, if you think about it. That's only one plane in a 3-dimensional system at best. So here's what we're going to do. You have to come up with this. So you've got to start with one of these final 2 equations. I'm going to start with 5x minus 10z equals 25. And if I'm going to find it in terms of z, I'm actually going to get the other letter by itself. I'm going to get the x by itself. So I'm going to isolate x. That should be an L. So I'm going to add 10z. And I get 5x equals 10z plus 25. Divide by 5. Divide by 5, and you get x equals 2z plus 5. So x is going to be represented by this. All right, now I need to represent y in terms of x. So go back to one of your original equations. Let me do x minus y plus z equals 7. X minus y plus z equals 7. And now I'm going to isolate the y. So take x equals 2z plus 5. Plug that in for x. So take x out. Put in 2z plus 5 minus y plus z equals 7. I'm going to move this y to this side. So I get 2z plus 5 plus z equals y plus 7. And I'm going to subtract 7. Well, 2z plus z is 3z. 5 minus 7 is negative 2 equals y. You can never get x equals 2 or if for infinite solutions or y equals 7. But here's what we got. We're going to list our ordered triples in the form x, y, and z. So x is 2z plus 5. y is 3z minus 2. And z is just z. This is how we write it in terms of z. So you need to write it in terms of one of these variables. And usually I like you to write it in terms of z, but sometimes that's not possible depending if you eliminated the z right off the bat. I also want you to do, for this case here, so that you have an understanding, I need you to list me 3 ordered triples that work. Okay, there's an infinite number that do work, and there's an infinite number of ordered pairs that don't work, or ordered triples. Well, all you got to do is plug in a value for z and then kind of go from there. And the easiest number to plug in is z equals 0. And so that gives me 5. That gives me -2. And that gives me 0. And then I can plug in z equals 1, which is 7. 3 times minus 2 is 1. And that gives me 1. And then z equals 2 would be 9. 3 times 2 is 6, minus 2 is 4, and then 2. So 5, -2, 0. That is just one of them. So if you would plug that in, it has to work for all of them. 5 minus -2 is 7, plus 0, 7. 3 times 2 is 15, minus 4, minus 0. 15 minus 4 is 11. 4 times 5 is 20, plus -2, minus 11 times 0 is 0. That equals 18. So you see how it works for all of them? So to be honest with you, infinite solutions, this is going to be the hardest one of the bunch, because you just can't stop and say infinite many solutions and move on. You have to list the solutions in terms of x, y, or z. All right, now that was in terms of z. I want to go through this again. I'm not going to go from the beginning. Let me see. I want to do something here. I'm going to clone that page. Okay. And I'm going to go down here and I'm going to get rid of some of this stuff. You can just pay attention. If you want to write this down, fine. I'm going to get rid of some of this here. All right, let me go back up to where we were. And so somebody can go a different route here. We still got 0 equals 0. We know there's infinitely many solutions. So that we start with one of the two equations. Well, they're the same equation. So 5x minus 10z equals 25. I told you to isolate x. The letter you isolate, you're solving in terms of the other variable. What if somebody went the other way and solved in terms of x? So isolate the z. You don't have to do both. You just have to do one, and they're going to be equivalent. And I get -10z equals -5x plus 25. Divide by -10. Divide by -10. I get z equals, that's going to be positive 1/2 x plus, no, they're not plus, minus. Now that works out to a decent decimal, 2.5, well, a terminating decimal. So that would be fine if you put as 2.5, or you could list it as 5/2. Absolutely cannot round off. So if this was 4/3, you could not make that 1.3. That would end up being incorrect later on. You could have to keep it as the fraction. But z equals this. Now what you got to go back, and we got to figure out what y is. So I'm going to go back to x minus y plus z equals 7. X minus y plus z equals 7. And you're going to have to plug in this for z. So x equals, or x minus y plus 1/2 x minus 5/2 equals 7. Well, we want to get in terms of x. I want to isolate y again. I'm going to move this y, and I'm going to move this 7 over. So I'm going to have x plus 1/2 x minus 5/2 subtract 7 equals y. Well, x plus 1/2 x is 3/2 x. And what do we get there? What's minus 5 halves? Minus 7. 7 would be 14 over 2, right? So that would be minus 19 halves equals y. Well, now we need to list the answers in ordered pair. We got x, we got y, and we got z. So if these are both written with the x in them, x is just x. Y is 3 halves x minus 19 halves, and z is 1 half x minus 5 halves. That would be your answer. Okay, you just cannot stop and say infinitely many solutions, boom, done. No, we got to go this extra route. Now I want you to list me 3 ordered pairs. Well, whatever the letter is, it's by itself. Just let that be rotate through. So I'm going to let x equal 0. Okay, you don't always get nice answers. So 0, that gives me negative 19 halves. That gives me negative 5 halves. Now I'm going to try and eliminate and make this a little bit nicer. I don't know if it'll matter. Let me do this. I'm going to just let x equal, 1 because I was thinking of letting them equal 2, but I think I'm going to let x equal 1. So that gives me 3 halves minus 19 halves, which is negative 16 over 2. So it's a negative 8. And 1 half x, so I'm going to let x equal 1 again. So it's going to be 1 half minus 5 halves. What's that? Negative 4 over 2, which is negative 2. Let me go back a second. All right, now I need a third one. I'm going to go back to something here. Of my 3 answers, I got 5, 7, and 9 for my x values. I got to get the same numbers. You can't get different numbers. So I'm going to let over here, and this is just because I already know it, I'm going to let x equal 9 for my third point. And let me go back a second, and if I've done everything right, if x is 9, I got to come up with 4 and 2. Got to. So let's go back here. So if I let x equal 9, we get 3 halves times 9 minus 19 halves. Well, what is that? 3 times 9 is 27 halves minus 19 halves. Well, that's 8 over 2. That's 4. And then I get 1 half times 9 minus 5 halves, which is 9 over 2 minus 5 over 2. That's 4 over 2, which is 2. So even though, depending on what numbers you pick, they all have to be the same. Now, like I said, you could have 3 different numbers from somebody else or 3 different ordered triples. But if you would happen to pick the same values, you have to come up with the same numbers. So this is in terms of x. Only have to find it in terms of x or y or z. If you can, solve it in terms of z, but if you've eliminated that variable, you're kind of stuck. And usually some are easier than the others. For z, we got nice whole numbers, okay, right here. Those are all whole numbers, so that's a little bit nicer. For x, we dealt with fractions. So I'm going to try to avoid fractions when I can. All right, so infinite many solutions, not as easy as in the past. You've got to come up with the ordered triples, okay, in terms of x, y, or z, and you've got to list me 3 ordered pairs. All right, that's it for the notes for today. Okay, here's the worksheet, and I just really need you to do 2 through, well, actually, it's just going to be, all right, 2 through 5. Make that 2 through 5. Don't do 6, because we actually didn't even talk about 6, and if you try to do it, you better look it up in the book for fun. So do 2 through 5. That's 1, 2, 3, 4. And then 7 and 8. Here's 2 word problems. Set them up. Solve them either substitution or elimination, okay? Substitution, elimination. When you get stuck, come to a Canvas conference. We can go through it. All right, everybody have a awesome day. We will talk to you later.